Howdy. This is Mr. Potter. So we're continuing our discussion about array lists, and there's a couple of things that I'd like to talk about in today's episode. The first thing I'm going to do, though, is I'm going to set up my import statements for what we're doing today. Remember that we are talking about array lists, so I need to import java.util.ArrayList. And the second thing is I'm going to be using the scanner, so I'm doing java.util.scanner. Now, what some people will do is they'll do import java.util.star just to import all the classes from the util group. The problem with that is that you're importing a lot of stuff, and your program actually ends up being a lot larger than it needs to. And also you run the issue of any classes that you define may conflict with other classes in here. It's usually good practice to just import the particular classes that you need, unless there's a reason that you're doing this for speed. For example, if you're doing a computer programming contest, you may want to import star from a set. So I'm using the scanner because I wanted to talk about one of the things that we discussed last time. The idea is that when I create an array list, I can't use primitives. I have to use classes, and that's probably one of only a few downsides with using array lists as opposed to just using standard arrays. It's very simple for us to just do int array foo gets new int 10 if I want to deal with an array of integers. If I want to deal with an array list of integers, it's a little bit more work. So what I'm going to do is I'm going to just set up a real quick loop for int I get 0, I is less than 10, I plus plus, and I'm just going to set up a scanner as well. So scanner in gets new scanner system .in, and I'm going to prompt system.out.print enter an integer, and I'm going to read in an integer. So int val gets in dot next int. And what I'm going to do with these integers is I'm actually going to create an array list to store these in. But I can't do an array list of int. That's going to cause a problem. So if I do array list int list gets new array list int then this is going to cause problems. It's going to not know what to do with this int up here. Notice those are the errors that I've got. What I have to do is I have to use what we call a wrapper class. There's actually a class called integer. And this class we've seen a little bit before when we've done integer.parseInt, or when we've looked at the integer methods or the integer instance variables such as maxint and minint. But we can also create integer objects. What I can do is I can say, instead of saying int val gets in.nextInt, I can say integer val gets new integer int.nextInt. So I can use the constructor to create I can use the constructor to actually create an integer object. But you can, in fact, just just do this. In .nextInt, this is something called auto wrapping, where, because Java knows that the integers class and the int primitive are so closely related that it can just automatically put those in. It's kind of like I don't have to use a string constructor to create a string. I just have to use a string literal, and Java gets it. And it does the same thing with integers. And it will do the same thing with doubles, with the Boolean class, and with the character class, which is the name of the class that we use for chars. So I can say integer val gets in.nextInt, and then I can say list.add val. And yeah, I could have made that just into 2 lines, and we'll do a system .out.println val, and I should see all of the values that I've entered. So let's go ahead and run this. Not val, list. Because val's not declared in the scope. Val's only declared in these integers. So enter an integer. I'm going to type in a 7 and a 3 and a 29 and a 4 and a 4 and a 77 and a 13 and a -2 and a 439 and a 0, and I need one more integer. How about 987,654? And so there is my array list, and it's printed out all the objects in here. So that's the first thing that I want to talk about, the idea that I could use the wrapper classes for integer, for double, for character, and for Boolean to create an array list of quote-unquote objects, when in reality I'm still really dealing with primitives here. So I'm using the wrapper class integer to deal with ints. And we have other wrapper classes. So other wrapper classes would be double, Boolean, and character. So for all of the primitives that we have, each one of those primitives has a wrapper class that we can use in these instances where it's gotta be a integer. So I've got this system.out.println list, but I want to do something else with this. I want to be able to go through the list, and we saw how we could do for int I gets 0, I is less than list.size, I plus plus, and we could system.out.println my favorite number is plus list.get I. And what this would do is it would print out a sentence that says my favorite number is blah for all the elements in our list. And so if I run this, and I type in numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Then there's my array list, which got printed out, and also I see my favorite number is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. But there is an easier way to do this. This is something called the Foreach loop. And the idea is I know that I'm going through this list. This list only contains one type of object, and I can say for integer I in list, and this will work exactly the same. As a matter of fact, I don't even have to say list.get I. I can just say I. And so what this does is it goes through the list, and for each element in the list, it creates an integer object called I, which I can treat inside this loop as an object. And so it's going to run this fine. So if I take these in 9, 8, 7, 6, 6, 5, 4, 3, 2, 1, and the number. Then it's going to go through that loop the same way, and ended up doing the 6 twice because it ignored the 7 because I typed 7 before it prompted. So there's my list in order, and what it does the exact same thing as the loop that we had before. What's nice about this is that this allows me, this is much shorter to write, and I can actually deal with the object in particular. So I can do all of the integer methods that we have. The integer dot get int. I can do other things. So, for example, if I'm dealing with strings, I could do substrings, or I could do index of. If I'm dealing with the fraction class that we wrote, I could do get numerator or get denominator or what have you. And I can do these directly as method calls from the object I in this case. The one thing you do have to watch out for when you're using these for each loops is that when you're using a for each loop, you're kind of stuck in the order you have to do it. You have to start at the beginning, and you have to work your way towards the end. So if I want to do a loop where I'm requiring myself to go backwards through a loop, then I really have to do this with an index. So I'm going to have to do something like for int I gets list dot size minus 1, I is less than or greater than or equal to 0, I plus plus. And in here, I'd have to do something like system dot out dot print line your favorite number is plus list dot get I. And this is going to be true if I need to call on any list methods for that particular element. If I'm going to call on list methods, then I need to know the index that I'm dealing with. And so this runs into this big question. Do I need to know the index, or do I just need to know the object? And the AP is famous the past few years for having a free response question where for the first part of the free response question, you're going to iterate through the loop normally, and so just getting the object is enough. But you're going to have to, in the second part of the question, you may have to go through the loop in a non-traditional manner. And this idea of going through a loop in a non-traditional manner you're definitely going to need to know the index of it. If you're going to go backwards, or if you're going to count by twos. Also, if you're going to make any changes to the list, then you're going to definitely need to iterate through the list rather than using the for each loop. Let's say, let me tweak this a little bit. What I'm going to do is I'm going to say that I really don't like the number 3. So I can't really say for integer I in list and say if I is equal to 3, or actually I can't even do that. I have to do die dot equals 3. Then remove it, because I can't do list dot remove. If I type I, remember that I is not an index. I is an integer. And so I really can't remove that object. I can only remove what's in cell 5 or what's in cell 8. So this won't work. I have to physically go through and say int I gets 0, I is less than list dot size I plus plus, and I have to do if I dot get, or if list dot get I dot equals 3, then list dot remove I. This will do that. This will get rid of all the 3s in the list, so then I can say system dot out dot print line a 3 less list, and it will print the list. So if I run this, let's do list dot remove with the semicolon, because that's what all the cool kids do. Let me run this again. So I'm going to type in 1, 2, 3, 1, 2, 3, 1, 2, 3, and 3, 3. So I've done this nice loop, and what I've done is, remember, my first loop using the for each loop is going to print my favorite number is 1, 2, 3, 1, 2, 3, 1, 2, 3, 3, 3, 3. But notice after I've gone through this loop, which removes all of the 3s, I've got 1, 2, 1, 2, 1, 2, and then the 33 is not a 3. So if I'm going to do something like remove things or change the list in flight, then I really need to use an index loop control variable, something that's actually going to go through each element in the loop, each element in the list by its index. But if all I need to do is just straightforward traversal and say, hey, are you this? Are you this? And just print. Then the for each loop is a wonderful way to go through this. So the two things we've talked about today is using a wrapper class to deal with our primitives that we're used to, such as doubles, booleans, chars, or ints, and also the idea of a for each loop to go through the loop. Now, the thing to know is that this loop always works. This is always going to work fine, and it's not going to have a problem. There are special cases where you can use this, and when you can have those special cases, when you can use this, then it's a wonderful space saver. It's going to go through. It saves you memory because you don't have to create another variable. But it is something you have to be wary of. You can't just willy-nilly use it. You have to think, is it an appropriate situation to use a for each loop? So once again, this is Mr. Potter. Thank you for watching. Have a great day.